So, let's just look at the application design. If you look at what we did last time, you can see this. So, let's start by creating a shift variable. I'm going to delete everything and start from scratch. And first, let's create an AUTOSAR project and design the application. You've created it, right? Yes, there's nothing there. Then, if you click on it, you can create an A-Haxan file. You can just create an AUTOSAR file. I created one. Let's create it like this. Once you create it, the schema is attached here. The schema is standard, so if it's XM8, schema number 49 is distributed by AUTOSAR. This is R2 to 11. What about R1? Yes, it's 48, right? 18, and 50 is 21 to 1, 51 is 22 to 10. So, the current trend among automobile companies around the world is moving towards R20. And after 20 to 10 days, if you're looking at the current trend, you can study like this. You can do R1 and R2 to 11. And if you later acquire a company, there's an X8 in R1. You'll need to convert it to R20 to 11. So the first thing we do is, as shown in the picture, we start with a simple variable. What variable? A variable that pursues application data. So, let's create a variable. So, the application data type designer came in, right? When you come in, there's a SIPL here. When you come here, there's something called SIP in the application data type design. See, that company's product can now develop for both the classic platform and the platform. You can write for both. There's even a temporary coffee tool. Here, there's nothing. So first, the standard data type is called an application platform type, and it's a SIP variable. I'll show you the prototype here slowly. So first, create a Genie flap type. Then, create a package name. Done. Then, if you click OK, this will be created. Regardless of your opinion, this is essential. The Moto Association also distributes files. This will ensure that your opinion is shared. So, this is the variable used by 10%. So, what I'm going to do is, I need to receive the vehicle speed from the application. That's because, when distinguishing between sequential, driving, and highway driving, speed restrictions are necessary. If you're investing, you can't invest at 100 km per hour, and you can't drive at 200 km per hour on a regular road. Of course, you can't even drive at 100 km per hour, but on this particular road, you can drive at 100 kilograms on a ghost road. So, whether this application will work or not, when parking, you must park within 30 km per hour. The law states that if you're within 30 km per hour, you're parked. Then, an application that helps with parking should be running. On regular roads, it'll be a regular road application, but on highways, it's particularly affected. So, we need to send the vehicle speed to the application. So, let's create a vehicle speed. So, in terms of data types, it's a CPP data type. The package name doesn't matter. We're just making it possible to distinguish between them. For reference, the package name has no effect on the source code. Since it doesn't exist, it's not important. So, here, we have a vehicle speed and a value. So, what does that mean? We need a type reference. A type reference. Yes, so vehicle VCL speed. And what's the reference type? UT, right? So, you can think of the value as a standard variable provided by 10 Pro. What's a tie reference? This value needs to be created from a reference. The file will be created by the bitstream. This will then become a variable for sending data between applications. You can create a tile reference separately and customize the vector array, string, map, type, and variant structure. Going any further would be difficult, so I created a vehicle speed. Yes, that's right. With vehicle speed, we're done, right? Next, you see, we created a data type. Next, we need to develop a service interface. Hyundai Motor Company is looking for people who can develop service interfaces. People who can write ACS. So this variable is already defined in the classic platform's CAN data. It's defined, but the classic platform is C, so we need to redefine the C variable in the classic platform into a carbon monophosphide place data type. Because the classic platform is C, we need to convert it into a variable usable in carbon monophosphide plural. Then, if we have an implementation data type, we can automatically convert it to a CPP implementation data type. You can get it directly from botconv. Next, the service interface. Where is the service interface? It's in the interface design, the service designer. So, let's click on the service interface and say, what should I call the interface? Yes, I'll use the vehicle space for EDAs. Yes, I'll use the space. I have to use it. I have to use the rain space. So this one also has a rain space. I created a service interface. Next, the event. What is an event? It's the same as the send, receive interface in the classic platform. Events are used for sending and receiving data. Let's change the interface name and change it to a service. Let's create an event. Add event speed. We brought in the data type earlier, so, like this. I'm leaving this out. this is the data type. I'll do this for the vehicle speed as well. This is the data type for AUTOSAR data vehicle speed. It's structured like this. I'm also a little confused because this company's product is constantly being updated. So, after creating a net space from the CP data type, I code the data type using this net space. I'm coding. The data type written in this net space is automatically upgraded by AeroComJet in the header file. This is the actual variable used, and it changed from interface to interface, right? It automatically receives the vehicle speed as an event from the interface. This is the service interface development up to this point. So, it's this simple. What's complicated about it? As I said before, it's about designing the service interface's net space well so it doesn't get overloaded. Then, it needs to be structured as an event so that it can be filled and sent in 15 seconds, right? In an actual hackathon, there are 5,000 data types. With those 5,000, you need to design an interface and attach them properly. So, if I explain what we're doing now, let me explain with a diagram. Let's create an AUTOSAR application. The actual vehicle speed is a motor. In the application, there's no vehicle speed. Next, let's say we have a port. This port is a port. The box is a type of a soft coupon. With the port, this port and this port are connected like this. So, what do we do with the interface? The AUTOSAR service interface we saw earlier is an event interface. This is the interface that provides data. This is what we design. So, when we provide data between applications, what do? We design the port. What is a port? Which interface do we choose? So, let's create an additive soft component. Inside, there's a port. A port is a service interface. We're designing this. We designed the reservation earlier, and now we're creating the data type and interface. Next, we're creating the application. So, developing the service interface isn't just about developing the application. We're designing the delta type and the service interface. So, where does the application go? Here, you can see the additive up constructor. So, where did we highlight the vendor? Then, you can create a soft component by clicking the Ochangmasu button. Note that ARM tags do not allow spaces or special characters. So, here, we created the AUTOSAR tag. Next, when creating a port below, the P port is for transmitting, and the R port is for receiving. In the case of an event, since we're sending data, we need to receive it. Since we need to receive vehicle speed, we can receive it through the R port. After that, the vehicle speed and interface are complete. The reason for this is because, for platforms like the Clash, the send-receive interface is designed based on various factors, such as whether it's RT Lite or not. However, for platforms like the Clash platform, we assume R, so we don't go into detailed design at a lower level. We just decide whether to use the interface or not, and we don't consider which R APIs we'll mix. We just use them all. Therefore, we have a high degree of freedom. That's why the design has reached this point. Next, it's on the HQ table. When I finish the implementation, I'll upload this Excel file to the Naver Cafe. The important thing is that the names are the same here, and at the application level, right? And the most important thing is that there must be at least one root soft comfort type. There must be one type. And then we bring in the occurrence we designed earlier. This is a rather important concept, and if I explain it a bit, then okay, the design is complete. If you look at it, the design is generated even if I don't use it, so we can do this. So, what is the occurrence root soft composite time? This is also available on the classic platform, but the concept is slightly different. The concept is that when creating an implementation file, this is the implementation file, and this is what I said earlier. This is what I named it. So, this application will use a soft component. This is the application type. This is what is used, and this is the tax rate. So, this is what is used. What is used is the root soft composite type. You can use one or more wherever application types, or you can use a composite component type. So, the reason this is important is that when creating a table, you can insert two application software component types like this. What do you need when inserting two? You need a component type from the composition. This is how it's needed. What this means is that this was an issue that actually arose in the field. Originally, we created two applications. We created two executable files. As we developed these two, we decided it would be better to simply combine them into a single C file. Then, we can combine them with minimal modifications to the existing source code. In that case, we can add a component and have the root software component type point to the comfort software component. This allows us to combine the two executables into a single execution file. That's when we use the Q table. The root software component can have one additive software component or two or more performance software, and this allows for two or more implementations. We use this. So, when developing, there are cases where two or more implementation files are integrated into a single development file based on requirements. In fact, you can actually move them around and reattach them. Yes, this is possible. That's why the concept is important. I'll upload this PowerPoint presentation to the cafe. This PowerPoint example is possible. So, you can think of this as application design. And when creating a reservation, you can validate it. You can validate it by clicking Validation here. If you click it, nothing appears, right? If it doesn't, it's a generator. So, let's run a debug here. Okay? Then, the data type we just created will be a source pod. Okay, let's create just one variable, like this. So, by slightly increasing and decreasing, and then slightly decreasing and removing, you can see the relationship between the two and the source code. Yes, that company has strictly enforced the JET rules. It's impossible to develop with just this much. Why? There's something called a surf stone. We're not doing it right now, so it's not feasible, but we're providing a way to make it work with just a little bit. It appears. However, if you look at it, the manifest file isn't created. To create a manifest file, you need to design the machine. Codes related to data types and service spaces also increase. If you look here, you can see that the AUTOSAR service I mentioned earlier is now AUTOSAR service. The type is the namespace of the service enter interface, AUTOSAR service. Since it's a service, a header file corresponding to that service is created. Even though there aren't many files written like this, a lot of source code is generated. The number of files is equal to the number of service interfaces. The number of files is currently one service pass event, as shown here. Since there's only one interface, only this appears. For one interface, there are 1, 2, 3, or 4 files. If there are 2 interfaces, you can discard more. If there are 4, you can discard them. So, as the number of interfaces increases, the ROM size inevitably increases. So, it is better to create as few service interfaces as possible and put many events inside them. That way, the RAM size is reduced. When I tested it, there were about 30 events, and when I created 30 service interfaces for those 30 events and then added 30 events to one interface, the difference was about a 30% increase. Of course, that is the difference compared to when there is no application logic. So, the service interface developer should put in events well so that the interface can be used as little as possible when the application uses it. That is why I even tried this agent. Next up is system design, which is a bit complicated. I'll explain this in more detail when I explain the pre-processing side. Now, let's take a look at the machine design. For each machine pass, there may be multiple A-class files in the machine design. Since that's possible, I'll add one more. Yes. So, we provide a function to split or merge machine reservation files. If you come here, you'll see the help contents. If you come here, there's something called a class index. If you see it here, you can merge or split a class and send it. In actual development, there are cases where there are 100x files, but they are integrated into a single access file. So, you can split the free 0 file. So, let's take a look at the machine design. Let's create a machine. We'll create a machine from a machine. Machine name is AUTOSAR, machine type AUTOSAR. If you look at what I said in the lecture on the first day, I explained that BMW has 7 active AUTOSARs on one CPU, so there are 7 machines. And in the case of a fully autonomous car, one CPU has 24 cores, so you can put 16 of them on it. That means there are 16 machines. So what we do for each machine is, when we run the board virtual area or board on each machine, a pararoot is entered. It's just that the computer from before goes into the home machine. In the example, machine 1 goes into each machine. So now there are 2 machines. You can understand it like this. So we have to design what applications we're going to put on each machine. So after creating the machine, what about the processor CPU to use? What kind of core will it use? Next, the OS settings, and then the log and trace log file recording are essential. This is what you press, the machine status value, the executable files that the machine will use, and the process machine mapping. So, first, let's add one processor to the processor, and let's say it's S32 or something like S32 or something like 23, yes, it's the implied CPU. I'll start by adding a 4-core machine from zero. If you look at BMW, it's one CPU with 24 cores. Each core out of the 24 cores is mapped to an Ultio platform. This will increase the number of Ultio platforms. That's why it's currently being used in the 4-core system. And on the machine, there's something called the True Platform Escape Table. This determines whether or not to apply security policies. Typically, you configure the true platform to either ignore or consider security policies. However, there's no precise source code guide for this in the standard. However, since OMI typically uses a non-security platform, and if you want to consider security policies, you can specify it in security mode. Specifying it doesn't guarantee it will be reflected. You need to use the platform rules. However, there's no standard guide for how to do this. This machine references the machine design. Machine design. Let's check the machine design. Isn't it listed here? You can find it. The machine design is now used to design the Ethernet switch. So, the machine design is about which CPU the application will be placed on, and the machine design is about which physical ports will be added to the machine. So, if we distinguish between machine design and the machine itself, the machine design is about which CPU port the AU will be used on, and then which internet devices the machine will use. So, the machine design can now decide which network, switch, etc. to use. So, for example, in the case of the actual Critica service, there are about 8 ports. Of course, it's multi-core. And now, you can choose which switches to use for each core. What I mean is, there's a real issue. The EU port, ET0, can have multiple ports. There are 1, 2, 3, 4, 3, and inside these are the cores. Cores, yes, CP cores. The queue has 0 and 1, and usually an even number of cores. If so, you can upload each core block to a specific platform. If you can upload, what you can do is define which core will use which device. You can design it this way or that way. So, as I mentioned earlier, which core will have an application is now part of the machine design, and which switch each core will use is part of the machine design. So, if I explain it to you, if you type in this profile, you'll see a network device. But in reality, the PC we normally use only has one. Just one. In reality, the issues applied to the AT flap are usually at least 2, or at most 8. Then, you can decide what to use for each core block. Because this cable has an exception-related ID port that must be protected from hacking, and there's another ID port that communicates with the cloud outside the car. We use that distinction. At that time, the machine is being used. So, later on, we can design this side. There are connectors, ETH0, and various other settings. This is complicated. Because it's complicated, the machine must replicate a single machine design. So, we connect the cores, CPU cores, and ports. And when we validate, we get an error. This indicates that the network isn't ready yet. That's why it's displayed. There's something about standard preservation. When designing a machine, you have to design all the endpoints, network endpoints, and other devices. So, if you look here, there's a cluster in the system design. What's a bit strange is that this cluster design is the network design of the classic platform. Classic platform network design is currently used alongside the WARE-T platform and this class platform. Because they're used together, it's difficult to design the WARE-T platform without knowing whether to design Ethernet for the class platform. However, in all my 15 years of experience in automotive, I've never seen a single lecture on network design. I've never seen one, but automakers need it. So, during this training, the company will explain the basics of design. So, the machine needs to be built, and then the process machine mapping needs to be done. So, here's the process machine mapping. I'll stop here and finish. Yes. Regarding the process machine, what I mentioned earlier is the actual process. If we briefly discuss the process, in the upgrade design, the company's constraints, as mentioned earlier, require the processor line names in the table to be identical. That's the app table. I've created one. Next comes the process. Now, the me part. This is how the mapping should be done. Next, if there's an error in JET, it shouldn't be there, but I'll probably try it. Okay, it works. So what happens? This creates a sequence manifest file and a machine manifest file. This is the S machine. On this machine, we'll use the S application executable. The manifest file is this sequence manifest file and the machine manifest file. So, there are files that affect the source code, and there are different files that affect the creation of the manifest file. In the case of SIFT, there is a standard for writing a certain AXM tag, and there is no standard for creating a manifest file that integrates certain tags. So, because of that standard, tool vendors and tool companies arbitrarily set it. If the system is already set up and has features specific to the automaker, you need to create a customized manifest file tailored to that specific function. Cybersecurity is a prime example. It involves security settings. For example, in City Chat, you can block specific applications from using the network entirely. What this means is that we've designed and coded each individual application to use the system, so that on the actual target board, the application can communicate with the system. However, if we apply the cybersecurity policy, we can block applications that aren't allowed to run. That's the key police policy. This is a specialized design for the system, and we can design it with these aspects in mind. I'll upload the design and operation to Café and also upload it to Facebook. Well, that's the end of today's lecture.